let's get into some Neo4j. So this is our graph database that we're going to be using today. The first thing I want you to do is I want you to just run this Docker command here. This is going to get our Neo4j database up and running. So this is going to open port 7474. That's where like the browser experience is exposed, and this port 7687, which is actually the communication port where you can actually have like your Node app write to Neo4j. We're going to say no authentication because we're just doing this locally for fun on our computer. Obviously, you would not do this in production. You'd have like advanced credentials and things like that. And we'll be on version 4.1.3. So I'm just going to copy that command, head over to my terminal, paste that in there. And now if I see docker ps, you can see here I got Neo4j running. And now I'm going to connect to it with something called Cypher shell. So I'm going to copy this one here, paste that, and that will now connect me to Neo4j in the Cypher shell. So what is Cypher? Cypher is actually the name of the query language for Neo4j. Just like you have JavaScript for MongoDB and SQL for Postgres, the query language for Neo4j is called Cypher. It's not the only query language for graph databases. In fact, I think Cypher actually just works on Neo4j, but there is one called Gremlin that works with kind of a wider variety of databases, including things like Cosmos DB. Okay, so let's get into actually creating our very first node in our database here. So we're going to be talking about the movie Scott Pilgrim versus the World, which is like one of my favorite movies. So I'm going to subject you to my personal preferences of movies. And we're going to create our first node here. So I'm going to say create. And again, it's optional that you capitalize this. You can also say create just like that. I'm going to capitalize it for your benefit. Create, and we'll make a p person. So this p here just represents a variable. We're not going to necessarily refer to it right now, but this colon person right here, this is the label that we're going to put on this particular node. So it's going to be a person, and then we're going to add some attributes to Scott, not Scott, Michael Sarah. So we're going to say name Michael Sarah, like that, who plays Scott Pilgrim in Scott Pilgrim versus the World. And Michael was born in 1988. So these right here are the properties or attributes of this particular person node. So person here, this is called a label, and these are called the properties. Okay, and then I'm going to close that and put a semicolon. And now I've added one node and set two properties and added a label to that. So now what happens if I want to query for this particular node that I've made? I'm going to say match p like this. So again, using a variable. You can say person. This is just a variable name so that we can refer to it later. I'm going to put p because I'm lazy. And I'm going to say name Michael Sarah. And this is how I'm going to query for that node that I just created. Here at the end, I need to put a curly brace there. Here at the end, I'm going to have to say return, because you have to do something with that node that we just queried for. I'm going to say return p, and you can see here we have now queried for this Michael Sarah node that we've created. We could also have queried for it just like this. So p person, like that. This is going to match every person in the database. Now, in this particular case, we just have one node in the database, and it happens to be a person. But you can see there that also matches Michael Sarah. Or if you want to just get every single node, this is going to match every single node, which again, we just have one node in the database, Michael Sarah. Okay, let's create a second node in our database. This node is actually going to represent the movie Scott Pilgrim versus the World. So we're going to say create m:\movie. Again, this m here just represents the movie that we're creating. It represents the variable, right? Or it is the variable, rather. And then we just have to give it all of the attributes that we want to give it. So create movie with a title of Scott Pilgrim versus the World. It was released in 2010. Its tagline, and I'm not making this up, this is actually the one that someone in marketing chose for Scott Pilgrim versus the World. Tagline is an epic of epicness. Someone was like really self-impressed when they came up with that line. Okay, and then we'll close our object there. So that'll be all of the properties. And then we'll close that. And then here, if you want to, you can say return M. This will both create it and then it'll return it so that we can inspect it, right? So now we can see here's the movie thing that we just created. It added one node, set 3 properties, and added 1 label. Cool, so now we have 2 nodes. So if I run that same query, match P, return P, I should get 2 things back, 1 person and 1 movie. As you can see here, I get 1 person and 1 movie. Now I want to create a relationship between Scott Pilgrim and Michael Cera. I want to say that Michael Cera acted in, and that acted in is going to be the relationship or the edge between those 2 things. So that's that Michael Cera acted in Scott Pilgrim versus the World. So the first thing we have to do is we have to match both of those nodes. So I'm going to say match Michael person, comma, Scott versus World, which is a movie. Now, honestly, I could stop here because I literally only have 1 person and 1 movie. But let's go ahead and make this a little bit more qualified. So I'm going to add a where clause. I'm going to say where Michael, again, Michael just being a variable that represents Michael Cera, dot name equals Michael Cera, and Scott versus World dot title. I did call it title, right? I did. Okay, cool. Title equals Scott Pilgrim versus the World. Oh, versus the World. Okay, and I'm going to say create a relationship with Michael on one end. I'm going to put a dash here. Then I'm going to put a relationship between these two, so that I'm going to do that with a kind of square bracket. And I'm going to call this a R, or you can call this a relationship or something like that. I'm going to say relationship. Acted in. So the important part is here. This relationship, again, represents a variable. Acted in here, this represents the type of relationship that we have here. So the type of the relationship is that Michael Cera acted in Scott Pilgrim versus the World. And this also can have properties of its own. So the role that Michael Cera had in Scott Pilgrim versus the World, if I do this, is he had the role of Scott Pilgrim. Now, this is actually going to be an array here, because as you can imagine, like if we're doing like the Nutty Professor, Eddie Murphy had like 5 roles in that movie, right? In this particular case, Michael Cera was just Scott Pilgrim, so we'll just close it at that. Okay, that's all the properties that we're going to put here in this relationship, but we could put as many as we want. And then we have to close the square bracket. And then we have to describe, again, this is a relationship, so I'm going to put another dash here, but I want to describe the cardinality of this, the direction of this particular relationship. That's Michael Cera acted in Scott Pilgrim, so there's a direction with that. So I'm going to put this arrow here, right? Again, this is just a space with a angle bracket at the end of it, but when I put those together, my font combines them. What actually looks pretty nice with this particular setup here. So Scott Pilgrim here is going to be Scott versus World. This is going to represent the movie, right? Now I could hit semicolon here and hit enter. This would be done. But I just want to return the relationship here so I can investigate that. So if I put semicolon here now, you can see here it created one relationship and set one property. And the relationship that it created here is an acted in relationship of Scott Pilgrim. So this is one of the things that I like about Cypher as a query language. This is actually based on like ASCII art, and they actually explicitly say that they did this so that you can kind of read it like a picture. So we have one end of this relationship, and then we have this like this particular thing right here. In fact, let me just copy and paste it so you can see here kind of in a vacuum. It's meant to read like a big arrow. In fact, if you just kind of like pared this down a little bit, it's supposed to look like this, where you have like, you know, A, then a relationship to B, right? So it's meant to kind of like read like a big arrow. But when you have a bunch of stuff in here, it kind of gets like drawn out, right? Cool. Last thing I wanted to kind of call out here is kind of this, you'll notice the casing here that looks a little weird. So one, these relationships are always described in screaming case, right, where everything's all uppercase. That it doesn't have to be that way. That's just kind of convention so that it's really easy to see that this is a relationship type. Whereas you look at something like the label here, like this one, it's in capital case again, so that's very easy to recognize at a glance that this is a label type, not a relationship type. It's something that people in the Neo4j community do. It's something that the docs recommend, so I just recommend that you do that too. So the next thing is we're going to copy and paste this really long query here that adds the rest of the actors and actresses and directors to Scott Pilgrim versus the World. So, I guess hold on, that's going to fail. I'll try that again. So if we do that, that added 7 nodes, created 7 relationships, and set 20 properties. You can see here we added Aubrey Plaza, Brie Larson, Anna Kendrick, all these actors and actresses to Scott Pilgrim versus the World.